Hello, welcome to ANS Solver. This is the fifth question of the paper. So, the amount of money in dollars spent by a customer on one visit to a certain shop is modeled by a normal distribution. So, they have given us the variance here, which is 1.94. So, I always suggest that you write all your information down so that you are clear with everything. In the past, the value of the mean has been 20. So I can say my mean is also 20, which is the first claim. But following a rearrangement in the shop, the manager suspects that the value has changed. Okay? So this is neither a decrease or increase in the value. He's just saying the value is different now. He takes a random sample of 6 customers, okay, and notes how much they spend. So these are basically the readings. Now the manager carries out a hypothesis test using a significance level of alpha percent. The test does not support his suspicion. Find the largest possible value of alpha. So what we basically need to do here is, I know my n is 6. I need something called as the test value here first, which is basically the summation of x over n. Okay, because you need to test it with the value. So now I can say this is basically 17.6 plus 23.5 plus 17.3 plus 22 plus 31 plus 15.5, okay, over, I can say this is simply 6. So what I can do is I can simply calculate this on the calci. So 17.6 plus 23.5 plus 17.3 plus 22 plus 31 plus 15.5 over 6, which gives me my answer as 21.15. So I know my test value now. Now I'll state the null hypothesis, which is basically the mean, which is equal to 20, and my alternative hypothesis will be the mean that is not equal to 20. Why is it a not equal and not an increase or decrease? Because the manager is testing whether the mean has changed or not whether it has increased or decreased. So now what I basically need to do is, because I don't have my significance level, I'll first calculate my z statistic value, okay, which is given by the formula the value minus the mean, okay, over the standard deviation over root n. Now I know my value is 21.15, which I calculated here, minus the mean, which is 20, over the standard deviation. The standard deviation is basically the square root of 1.94, because the standard deviation is the square root of the variance. So I can simply write this as the root of 1.94 over 6, because 6 is basically the number of people, okay, he took. Now what I can do is I can calculate the z star for this. So I can simply use my calci for that, okay, and the value I get for that is simply 2.022. Okay, now comes the important part. Here, if you see, the test does not support his suspicion. That means you have accepted your null hypothesis, okay, and you have rejected your alternative hypothesis. So when do you accept the null hypothesis? When your 2.022 is less than your z value which you obtained with your significance level. That means on a curve, I know it's a two-tail curve here because your alternative hypothesis is not equal to, but we'll focus on this tail because I need the largest value. So now I know 2.02 lies somewhere here. Okay, so now what I can do is simply I can calculate the value which is more than 2.022. So how do I do that? So you can go on the calculator, okay, click on mode, click on option 3 where stat is written. Okay, and then you can click on AC, and once you click on AC you can click on shift, and then you can click on 1. When you click on 1 you can simply click on 5 where distribution is written. Now on your display you'll get something like 1p, 2q, 3r and 4t. P basically means less than of the Z value, and R basically means more than. Q and T are not needed that much. We are more focused on P and R. Now here if you notice, I basically need, if you see, I need the 1 minus phi of 2.022. Correct? 1 minus phi basically means more than. So I'll click on option 3. So when I click on option 3, I'll get something like R with a bracket here. So in my bracket, I simply put 2.022. Okay. And when you do that and click on equal to, you get 0.021566. But now, is that the final answer? No. I told you all it's a two-tailed test. That means there's another tail lying here. So we need, the area here also. But I know the area in red is always equal. So what I can simply do is, I can simply do 0.021566 plus 0.021566. Okay. And when I do that, I get my answer basically as 0.04313. Okay. But now this significance level needs to be a percentage. Okay. So I can simply write this as 4.3% or 4.31% as the final answer. Okay. It's a very good question. They have tested you here in a very good way. So yeah,